Hi, here this is Smart Academy. We are giving CSIR Physical Science online classes. Now I am discussing about problems on classical mechanics regarding to applications of Lagrange's equation. So I am discussing about problem number 6. That is, the question is, obtain the equation of motion for a particle falling vertically under the influence of gravity. This is a situation: the particle of mass m, it is falling under the gravity from a height y. When frictional forces are obtained from dissipative function. So when it is falling, frictional forces are applied on this particle. Those dissipative function of kV square. Dissipative function is equal to of kV square are present in this one. Integrate the equation about to obtain the velocity of function of time. So up to now we complete first here. Then we go to second part. This is the first part here. See, this is xy axis. This is the mass of particle m. It is falling from a height y in the frictional forces in the function of kV square. At time t equals 0, u equal initial velocity is 0. It is falling from rest. The maximum height is h. So while it is falling, the maximum height is h minus y. The difference is there. When y is changing, h is decreasing. Y is decreasing, so h minus y is the difference of maximum height minus changing height. So what we have to find here, should the maximum possible velocity for fall from rest. What is the velocity here? We have to find this one. This is the second part. First we have to find the equation of motion for this one using Lagrange's equation. So a Lagrangian equation for a system containing frictional forces, divide dt of dou L by dou qk dot minus dou L by dou qk plus dou R by dou qk dot equals 0. See, here the frictional forces term. This is generalized coordinate Lagrangian equation. So what we have here, first step is generalized coordinate. Generalized coordinate y. So in terms of y, just we write Lagrange's equation. That is d by dt of dou L by dou y dot minus dou L by dou y plus dou R by dou y dot equals 0. So what is the second step? Kinetic energy of the system, that is equal to R m. So my dot square. The y is the distance from is the distance of the particle from the x-axis. This is the y. So that is y dot is velocity of mv square, that is equal to of m y dot square. Okay, what is third step is goes to potential energy, that is equal to v. V equal to mgh mgy. So the y-axis is above the xy plane, xx dash line. So that is positive mgy. So one more here we have Rayleigh function, that is equal to of kV square frictional force. So that is dou R by dou y dot, that is equal to dou R by dou v. Y dot means velocity, that is equal to of kV square, that is equal to kV. Differentiation, that is equal to kV, that is equal to in terms of y dot. So okay, now we have kinetic energy we got, that potential energy we got. Fourth step is Lagrangian. Lagrangian equal to t minus v. T equal to of y dot square minus k y dot. Potential energy mgy. Sorry, here mgy plus dou y dot, that is equal to ky dot. This is a Lagrangian equation. So k equal to, okay, we got this one. So what we have, d by dt dual by, what is in Lagrangian equation, dual by dou y dot, dual by dou y dot, that is equal to half 2y dot. So there is no y dot term, the last term it is there, that is okay, this is 2 to my dot y double dot means my double dot. Sorry, it's missed. See, don't include this one. L equal to t minus v, L equal to 2 minus v, then this is half m 2 y dot, so we get my dot x dual by dou y, we go minus mg, then substitute here d by dt dual by dou y dot my dot minus dual by dou y, that is equal to mg, plus dou r by dou y dot already we have, that is equal to ky dot equal 0. So finally my dot mg like ky dot equal 0. This is a Lagrangian equation of motion. Equation of motion for the particle, it is falling from y to y. So this is the first part of the question we complete. What is the second part? Integrate the equation to obtain the velocity as a function of time. Show that the maximum possible velocity for fall from rest. If it is falling from the rest, what is the maximum velocity if we fall here? That is equal to mg by k. First part over. We are moving to second part now. What is the second part? My dot plus ky dot equal to minus mg. Here integrate the equation to obtain the velocity as a function of time. So now I am integrating ky dot c plus c. So we will get m y dot plus ky equal to minus mgd plus c. So then from here mv plus ky minus mgd plus c. So we have this equation now. So we integrate the equation to obtain the velocity as a function of time. So this is will be equal to here, but the conditions are, according to condition at t equals 0, at t equal to 0, initial velocity u equal to 0, maximum height is equal to y equal to h. Substituting this equation, mv plus kh minus y is the changing distance, height, then minus mgt, then what will get, v equal to minus gt plus k by m of h minus y. So this we have the equation now. What we are doing now, so we have this equation, v equal to minus gt plus k by m h minus y. Differentiating about the equation with respect to time. So differentiate this equation with respect to tire. dv by dt minus z plus k by m minus dy by dt. So here dv by dt is at maximum velocity. If v is maximum, dv by dt equal to 0. When v is max, differentiation now with respect to time, that is equal to 0. So at maximum velocity this is equal to 0, then minus z plus k by m, this is v, dv by dt is nothing but v. So this minus will be there, minus already is there, minus k by m into v. So v equal to mg by k. So this is the second part I finished now. So this is the second part. Finally, to show that the maximum possible velocity for fall from rest, it is that is equal to mg by k.